Hi, everyone. I'm Robbie from PocketLab, and today we're going to be talking about heat islands with our special guest, Patty Laramore. She's a teacher in Atlanta, Georgia, and she knows a ton about heat islands and the concept of heat islands because she's done a lot of experiments with her students, and that's what you're going to be doing today, learning about heat islands, and then we're going to go out and actually measure some heat islands and collect data. So Patty, can you explain what is a heat island and how are heat islands studied?
So a heat island is when you kind of talk about these, an area that is significantly changed by the adding of concrete, pavement, steel, and all these other structures that take away from the natural environment. So your temperature is usually hotter in an urban area than it is in the rural area that surrounds it.
Hmm.
And this can have an impact on weather. It can have an impact on behavior of and animal and all the diversity that goes along with it. So what we're doing to study it is we go out and we actually find out these pockets around these urban areas where the heat kind of intensifies. And in some of these areas, you can actually get temperatures that might range from 1 to 4 to 6 degrees, and even in some extreme cases, 10 degrees hotter than it would be in a neighboring area that was more rural.
So if there is anything that humans have done to the environment, like added a parking lot or added buildings or anything like that, that's going to have an effect and create one of these heat islands.
It absolutely could. And so what we look at is kind of cities are so large, they cover square miles, and the density of that material is so thick that it tends to have this larger impact on people. And so yeah, so anything, it doesn't have to be just replacing it with these unnatural surfaces like concrete, steel, or asphalt. It can simply also kind of be cutting down a forest where you lose the canopy, like to shade that ground area or to provide some more evaporation from the trees. And how water flows is actually a big one because the surfaces get so hot that it changes the temperature of the rainfall when it hits the water and can change lots of different things in surrounding communities as well.
So we have Jason from Pocket Lab, and he is out at a grassy field. So kind of more of a natural environment. And he's got a Pocket Lab sensor so he can measure the temperature. And so he's going to go out and do some data collection similar to what you've done with your students. So let's go to Jason and so he can show us how to measure some the temperature in a grassy field. Jason?
So I'm here at a local park near me where I'm going to be measuring temperature data using my PocketLab Voyager and this external temperature probe. So I'm going to be measuring temperature out here on the field and then measuring temperature just over there in the parking lot, and to see how the temperature varies from location to location. So I'm going to connect my sensor to this iPad and start looking at temperature data. So I'm getting paired. I'm going to select the temperature probe and set this to Fahrenheit. And I'm going to hit record. Alright, so we've started recording data now. Looking at this right off the bat, we're reading around 70 degrees Fahrenheit, so it's a pretty nice day here today. I've been waiting for the weather to be nice and sunny for this experiment. While this is going, I'll take some observations around us. So it is a pretty sunny day. We're recording here in direct sunlight. There's a light breeze that's blocked by some of these buildings and trees around, but still feeling that a little bit. Oh, just a cloud just covered the sun, so we're seeing a drop in temperature now. So that can definitely affect our data, but we're still looking at the air temperature here. So I'll wait for this to level out a little bit. But I'll make some other observations of this area. So we're There's a playground nearby, there's some houses behind me. We're kind of in the middle of a neighborhood. This is kind of the biggest green space around, so it's just a pretty big field of grass. It looks like we've leveled out here around 65. So I'm actually going to measure surface temperature as well. So I'm going to drop this down in the grass and see how that affects the temperature. The wind's picking up a little bit. So there are a lot of variables that can affect your temperature measurements, so things like wind and direct sunlight, but also where you're measuring. So down in the grass here, we're seeing the temperature increasing pretty steadily. Just the grass was going to increase from the sun more than the air around it. So you might see bigger changes in temperature down near the ground than you would see up here in the air. So it can be helpful to look at both and see how those temperatures differ. So we're starting to level off here around 83. Maybe it's going to creep all the way up to 84, 85. So much warmer down in the grass than it is up here at chest level.
Thanks so much, Jason. So what we saw was that Jason was out in the grassy field, and he used his PocketLab, and he measured a temperature of about 70 degrees right around in that grassy field. So now he's going to go to more of a less natural setting. I know that park was probably made by people as well, but it had grass and trees and things. So now he's going to go to a parking lot on the same day, just very close to that grassy field. And he's going to measure temperature there as well. And so, Patty, in your experience going out with your students, what do you think is going to happen when he measures the temperature there?
Well, I think the temperature is going to be higher. I think it'll be interesting for me to see what the difference between the air temperature is versus what it is at the surface. And because the difference can be extreme. I think I feel that when when you're walking barefoot, you kind of feel the differences on your toes and you jump onto that grassy nook. But I'm kind of excited to see what he's going to do.
All right, so let's go see. Jason?
So I'm out here on the parking lot now where I'm going to see if there's any change in temperature compared to out on the field. So again, I'm going to connect my PocketLab sensor and start collecting temperature data. So right away, looks like our temperature readings are a little bit higher, but it looks like we're leveling off here around 73 degrees. So our kind of average temperature over on the other side in the sunlight with no wind was around 70 degrees. So it looks like things are a little bit warmer here, maybe 2 to 3 degrees warmer, just baseline. And again, things like being in direct sunlight, if there's cloud cover, if the wind picks up, those will affect our measurements. So wind's picking up, sun's kind of going behind a cloud, we're getting down to 70 degrees. But still not as big a drop as we saw when we were over on the grass. So it looks like things are retaining a little more heat here. Even just standing here, I can kind of feel some of the heat radiating off the ground. So I'm actually going to put this down and start measuring that surface temperature again to see how much different it is down there. So some observations of this area while we see this graph steadily rising. I'm here in not too big of a parking lot. There's still trees around, so it's not a completely urban space. There's still greenery around, but the main difference here is that the ground is all asphalt instead of grass. So we're seeing how that affects the temperature here. So already our temperature is up to 86 degrees and still rising, so much warmer down on the asphalt than it was in the grass.
Thanks, Jason. So what we saw is that when Jason was holding it, at shoulder level, it was about 73 degrees. So like you said, Patty, it did get warmer just right in that area. And then, as you predicted, when he put it down on the pavement, it went way up to something like over 90 degrees. And we'll see that data. You can see that data later on in the lesson and check that out. Exactly like we predicted, if you're for the students out there watching this that are going to go out and try and collect this data as well, how can they go out and study heat islands on their school campus?
So I love that what Jason did was kind of like the two extremes. You go from, green to asphalt art, totally artificial, and you can see the differences. But I think on campuses, there's a lot of intermediate. Most of the campuses not so cut and dry, which is which. You might have a football field that has artificial turf.
Mm-hmm.
You might have bleachers that are made of metal. Maybe you have parking lots that are not asphalt but are concrete, so they're more lighter color, where the albedo is a little bit different than it was in the dark areas. Or maybe you're fortunate enough to have woods or even a stream or a water feature on your campus that might be able to give you some information about how can we solve some of these issues to normalize the heat, to make it more livable even. I think that it got really hot when he dropped that on the asphalt, and I don't know if I know I don't want to live my life at 95 degrees sometimes. So
yeah,
and I live in a big city, so
that's really interesting. I never thought about how it makes sense, but a football or soccer field, just because you have that on campus, if it's actual real grass versus artificial turf, how that makes a difference. They're both green, but for the color and maybe for the albedo, but they're very different materials. And so even trying to go out and see the difference between that would be really interesting. Maybe you have a grass field at your school and artificial turf, and you could see how those are different. That would be really interesting as well. So I think one thing that students can do is think about your school campus, think about the different features at your campus, and try to come up with some places that you would like to test to see, is there a difference are there these sort of micro heat islands at your campus, and where might those be, and why might those be there? So that's something that you can all do as students. You can kind of think of your campus and think where are some places that you might want to test. Now that we've thought about, what are some potential micro heat islands on our school campus, and what heat islands are in general on a large scale, what is bad about heat islands? What's so bad about having certain places warmer than normal because of these heat islands?
Yeah, and I think a lot of the issue comes with the fact that we don't like to be uncomfortable. And so to regulate our climate, we use air conditioning, which is mostly fueled by fossil fuels, which can then, go right into that positive feedback loop where we need more fossil fuels, which are putting more carbon dioxide in the atmosphere, which is making things hotter, which is going to make the cities hotter, which means we need more air conditioning. And that expense goes with it. The use of our non-renewable resources goes up. We also see that it affects people's comfort. If you go outside and it's brutal hot, you're just not comfortable. And it can affect the environment because the pavement's hotter. It can affect how the water runs off, and because pavement is designed to kind of take that water and off into storm areas, the water heats up, and you get this thermal pollution that goes on into our water systems. Of course, there's not a lot of nature usually in a city anyway, but what does survive there finds it hard to thrive. And then, of course, because there's so much expense with trying to be comfortable, there is some social issues with that, of where people live in cities and can they afford to stay cool when heat stress could become such a disadvantage for those on fixed incomes, or just don't have the resources to pay for those extra air conditioning bills.
Yeah, that's really yeah. So, if you look at a city, a map, I mean, you can look at your school's campus and find, oh, where are the little places that might be warmer than normal. But you can also look at a city map and you can say, well, this place has more parks, or these streets are lined with trees and these ones aren't. And why are certain streets and neighborhoods have more parks or more natural environmental elements to them like trees, and why do other neighborhoods don't? And is that equitable? So is that something you've kind of talked about with your students as well?
It is, and it's something that we look at, that we talk, they find interesting. And there's actually some good information out there, especially with the Atlanta heat island study that was going on. There's some pretty good data out there about relating, income, race, industry to these different areas of where it's hotter. And it's really neat kind of side offshoot of the science of how that science actually applies to city planning and urban development, and how can we make our cities more friendly,
Yeah.
environmentally friendly.
So Patty, you touched on this a little bit about, city planning is a way that we can try and improve heat island situations, kind of at a larger community. What are some other things that maybe your students have come up with for their school, specifically for their school's campus, or other things about their neighborhood? What are some things that we can do to help with heat islands?
Well, I think that's the best part about this whole project, and finding out where the differences are happening. A lot of the heat island effect happens at night too, where the structures are re-radiating all that heat back out, and so they never get that chance to cool off or get away from that stress. So our kids have done lots of different things, from the small, like maybe adding a lighter color asphalt, like just changing the color just a little bit, not black, but we're just going to make it a little color. Or planting more trees is always, it just adds the canopy and the shape, to really extreme type of things where you are putting solar panel tunnels over roads. So then you're only getting, you're getting the energy use plus shade, or green roofs, something that actually beautifies more park space, building vertical instead of horizontal. I don't know. I can't wait to see what everyone out there decides to do, because I think that's where the innovation rests is, don't you have to use my ideas. You can find your own, and there's so many that can just apply at the school level, community level, the whole city level, even just by small changes.
Yeah, great. So I agree. I'm really excited to see all the different ideas that students come up with. So as part of this activity with your teacher, you're going to be coming up with some ideas of things that you can do to help with heat islands, both at your campus, at your school's campus, but also in your community. So when you go out there, now that we know a little bit about heat islands, you're going to go out and measure, see if you can find evidence of heat islands just at your school's campus. And then that can help you start to think about some ideas that you could do to help mitigate the effects of heat islands at your school's campus. And then, kind of try and think about what that means for your community. And can you take those ideas to your community? So, Patty, thank you so much for joining us today and being a part of this lesson. And we're really excited for you as students to go out and find some evidence of heat islands in your community and at your school, and come up with some really creative ideas to help with those.